Hey folks, so the boards came in, and so now we're ready to assemble everything. I got the parts from DigiKey as well, so we'll go ahead and run through this assembly video here. Really, probably what I'm going to do is do actual video on highlights of specific bits that I'm going to install. Like the chip here, I'll probably do actual video of. The rest I'll probably do time lapse of the less important, less interesting things. But we can do a quick quick look at the board here. Grab one of these and you show it off here. The boards come from Osh Park with these little tabs on them still. Osh Park uses these to attach your boards to a whole pile of other boards. That's how they manufacture them. It's a group sort of deal. Is they put everyone's boards together on a big panel, manufacture the panel, and then cut them apart. And so you'll end up with these little tabs on. And then what I do is I just grab a pair of pliers, and if you grab onto the tab, something like that, if you can see, and just kind of back and forth, they pop right off. And so I'll do that with the rest of the tabs. You can just throw those away. And then in terms of the rest of it, as we see in the schematic, we've got our input port here, our main chip, our inductor here, our output port here, as well as the alternate output port, the USB port here. These are our output capacitors down here. We've got our resistor and LED here for status. Some input capacitors. There's our protection diode. These are the two resistors that set our voltage. All the things that we went through in our schematic and our board design. And then, we've got our nice silk screen that we put on here. We've got buck regulator, all of our part labels on there, my maker's mark, so to say. And then on the back here, we've got it labeled, plus and minus on our output, plus and minus on our input, as well as, a date mark and then my name. I usually do try to be, good about putting my name and a date mark on them. Usually I try to put a more specific date on this, but because this is related to this video and it's a not particularly complex board, I figure I can get away with being relatively general. Often I like to do a more specific version number or a more specific date. So like I've got a random other board here, and so again, so this is the name of the board, my maker's mark, and then version 1.2, so I know which version this was in reference to the other versions I'm making of it. Anyway, so what I'll do is I'll finish busting off these tabs, and then I'm going to start placing components. Usually what I like to do is I'll leave the connectors till the end, and then I'll place the larger components, say this chip and probably this inductor, before I place all the little guys, just in case the little guys get in the way of me being able to reach any of this stuff. Because these are, this is more complex, and this is just bigger, where I need to get a larger part of the iron down into here, and if there's other stuff in the way, it may be more difficult. So what I'll do is I'll do these guys first, and then I'll go around and do all the little surface mount stuff, which should be easy to get to no matter what. And then last I'll probably put the USB port on this board. So that's that, and hope you enjoy following along. So we've got our regulator chips out here, and so I've got the other two here, and you can see the bottom here as the exposed pad. I'll bring that here so it gets into focus. It's just got that metal there on the bottom, and that's connected internally to remove heat. And so, we recall that we kept that in mind when we were looking at these parts, and so when we were designing the footprint on the board, we made it so that it could interact with that exposed pad on the bottom. So we left this portion here without any solder mask so that we could solder, that bottom portion to this part of the board. And then we did, another step there was we added these 4 vias, and we specifically made them larger than our other vias so that we could get the tip of the iron in there and get solder in there, so that after we take the 4 pins on either side and solder those down, we can flip the board over and look at the vias on the bottom and maybe stick the tip of the iron in there, and then from the bottom stick some solder through so we can make sure we get that pad soldered down really well to remove that heat. You get it well coupled to the board. It also is a good ground because those are electrically connected to ground as well. So that's a big help there in terms of getting these things soldered. If you didn't have these vias here, you would have to kind of use hot air to get that attached properly. Otherwise, it's not like you can get your iron, underneath there to put, solder on this pad after it's already been attached. So, you would have to use hot air to attach that part. But if you put these big vias in and flip the board over, you can put in solder from the back side and solder that part down without having to use hot air. I do have a hot air gun, but I also like to have the vias because it also pulls heat through to the back side of the board well. So, it makes it easier in a couple of regards. I don't think I'll probably end up using my hot air at all for this assembly. All of this stuff is fairly reasonably sized and well within my grasp. Plenty of size on the leaded parts here. There's nothing leadless, so I think it should be pretty easy to do. Then, in terms of the actual surface mount soldering, besides this little tip there, there's a million things on YouTube about how to solder surface mount. I don't think I'm going to add a huge amount to that conversation, but I can certainly go through the basics of what I'm going to be doing here. First off is you'll notice there's that little circle there in the upper corner of this chip there. As you should know, that indicates your pin 1, so that pin is pin 1. And we did the same here on the board where we added this extra bit of solder, not solder mask, the silkscreen, to indicate where pin 1 is, and so we know that that pad is pin 1. And so when we're doing this, we line up our pin 1 with that, so we know how the part goes. Okay, so we've got that. And my technique is generally going to be, I'm going to put a little bit of solder on one pad, set the part down, and get it placed with that one pad worth of solder, and then I'll go around and get the rest and add to those. So I'll go ahead and do that now. I've got my soldering iron warmed up, so I'll put that off to the side, lay this more straight, and then we'll add a little bit of solder. One thing I do note that I see a lot of folks doing is they use whatever solder that they've had for a million years, and it ends up being some huge size. You don't even have to do terribly expensive. This is a cheap Radio Shack little spool of solder, but the key is that it's really thin. When you look at it on the board, it's really thin. It says on the spool it's a 0.015 inch diameter solder. So that's what I found to be the biggest help, is that if you're using big stuff, it's way too easy to put way too much on. And in the same vein, I use a pretty fine tip soldering iron as well. So I'll just touch that pad, add a little bit of solder there. So the pad's wet now. It's got a little tiny bubble of solder on there. I'll pull my spool out of the way again. And then I'm going to grab my chip. I'm kind of going to place it generally, and then I'll move my hand around so I can actually, unfortunately the camera is really close my work area, so it's a little harder to maneuver than it is normally. But so then I'm going to kind of get it where I want it to be, get a good grip on it, gentle but firm, and then okay, I think I got it pretty well aligned, and I'll melt that pad again and then let off, and then that should be stuck. So yeah, now I can lift the board up by that chip. Again, be gentle, it's only holding on with one pin, but now that that chip is in place now, I don't have to worry about placing it anymore, so I can take my tweezers away, come back with my solder, and fill in the rest of the pads that I haven't gotten yet. So I'll hold it down with one finger back here, and then I'll go through and add solder to the other pads. In this case, I probably could have used a little bit more flux on the pads. The solder's not really wanting to stick right off the bat. And by a little more, I mean any, because I didn't add any. I do have a flux pen, maybe around here somewhere, that I'll probably get out for something like the big pads here on the inductor, just to help with that a little. But otherwise, we're doing okay. We just have to kind of get it to start. There we go. Alright, so now that's all 8 pins on that soldered. It's not the cleanest job ever, but it'll do. There's no bridges or anything there, so I'm happy with that. And that's kind of the general process. The same thing applies. What I was talking about earlier, where you tack one and then do the rest. The same thing applies to all of your other surface mount components. Is I'm going to put a little ball on one side, and then melt it and place the component, and then get the other side. Often on these surface mount components, I'll come back and retouch this one, but it's pretty much the same. Little ball, place it, other side. So you go through that with every part. Usually I break it up. I'll do capacitors first, or I'll do resistors first, but I'll do them all together and just work through my part list, from top to bottom, and then get that taken care of, and then soon enough you'll have a done board. If it's a really complex board, I'll try to break it up into assembling parts that I can test individually. First I'll say I'm going to build the power supply section, and then I'll power it up and say, okay, is it actually outputting all the parts, all the voltages I want? And then I'll build the logic section. Does the processor start up? Can I communicate with the processor? And then after that, I'll build the whatever's attached to the processor. Can the processor talk to these components properly? So if it gets big, then that makes it easier to test while you're building it, so that at the end you don't just say it doesn't work, I don't know why. In this case, it's a small board. It does one function. It has one active component. So really, it's going to be really simple. I'll just build the whole thing up, and it should probably work. So we'll go from there, and so I'll move on to time-lapsing it and build up these boards. Alright, and that's the assembled boards. I've left these connectors off. As I mentioned in the earlier video, that I designed those to be compatible with the Anderson power pole products. But in terms of general usage, they're also perfectly good as just points to solder wires to. And so for now, I'm just going to leave those unpopulated. I've got the USB jacks soldered in. And so what we'll do is we will hook up a voltage on the input, and then stick the multimeter on the output and see if we find anything. So we will see what we can do there. Let me see if I can, if I've got my leads available. I do have my bench supply here. So I suppose the initial test is all set at I don't know, 12 volts, and then I'm going to short my supply so that I can set my current limit. And for this test, because I don't have any actual load on there, I'm going to set my current limit to 50 milliamps or so. That should be plenty to power up the device, and also help, if there is a short or anything, prevent it from actually destroying anything. So again, make sure your polarity is good. You've got your minus and your plus there, and that corresponds here on the top, minus and plus. So I'm gonna just kind of stick my negative probe on there and my positive on here, and see what we can do. My supply says it's not drawing much, so I don't know whether it's broken or whether it's good. Let me see if I can get my multimeter on here. One of the things I could have easily done is put the LED on backwards. These surface mount LEDs don't have a great method for determining which direction they're going. Some of them do and some of them don't, but these ones don't. So it looks like this one is 1.24 volts on the output, which isn't quite right, but maybe there's something wrong with just this board. So let's try the other boards and see what we get. Alright, 1.33. And 1.28. So something's going on here. I'm not sure exactly what off the moment, but so we'll have to take a look and see what went wrong, and then figure it out and fix it. This is entirely not uncommon. It's more surprising to me often when a circuit works out of the box than the other way around. So it's easily possible that something else weird is going on. One of my immediate suspects might be like, maybe I put these Zener diodes in backwards, which is just going to essentially shunt these to ground at generally 0.7 volts, but that plus another transistor, say in here, you can easily get us into the 1.5 volt range. Maybe our set resistors aren't quite right, so we'll check those out. We'll look at what's happening in the coil on the scope, see what's going on there. So we've got some things to explore, and so I'll follow up on that in perhaps a next video, a diagnostics video, because this video is just the assembling and it's been done. So thanks for following along, and we'll see you next time where we figure out what's going on with these. But for now, these are built. They're looking pretty good. I think the board layout was good. There's no immediate issues there, so it's always nice when the board comes out well. So we'll follow up next time with figuring out what went wrong and fixing it there. Thanks for watching. Hey, so I ended up doing a little bit of testing here, and it was indeed my first suspicion there. So it ended up being super quick, and so I don't think it constitutes a whole nother video just for diagnosing it. But it was my first suspicion that it was this little, there we are, the Zener diode that we had added that was right there in the circuit. That either I had it backwards or I haven't tested yet whether to see it's just not the values we were really hoping for, but it was clamping the whole circuit down to a pretty low voltage, and so it was causing the switcher not to switch, and so it it would just shut off because it was a short circuit. So we can see now that the power LED is on. We were feeding it with the 12 volts from my power supply. Right now it's got about 20 milliamps worth of draw because it's powering a little OLED display. It's the same display from the MicroView on a little breakout with an electric amp. So, so it's powering that off to the USB cable feeding into there. And I've also got the multimeter hooked up, and so we can see it's pumping out at pretty much exactly our set point at 5 volts. So I'm pretty happy with the results. It seems to be working fine. So I'll pull the diodes off the other two, and see if they were put on backwards or just weren't the right values that I was really hoping they were. So anyway, thanks for watching, and thanks for following along with the series.